I recently did a project on my 2007 BMW R1200RT, and that project was to convert a good fuel strip to a float. The reason for that is the fuel strips in these models are problematic, and my warranty was running out, and I wanted to see if this float worked on my bike or not. So in the last 6 months I've been working on this project. I'm done with it now, and I created a DIY to help others do this, and that DIY is hosted on the BMW MOA forum. And unfortunately, that content isn't made available to everybody. You have to be a subscriber to the MOA. So I'm converting that content to this YouTube video to make it available to everybody else. Basically, I'm going to go through my DIY quickly and just try to cover all the content there for you. You may need to pause this recording in order to read everything that's presented. So go ahead and do that when necessary. I'm not going to read everything. I'm just going to try to hit the highlights, show all the photos and steps, and click on all the links so that you can see them in this video. So let's get started. Of course, we need to do the disclaimers up front. I'm not responsible for any damage you may do if you follow this. You've got to assume your own liability. You're going to be working around fuel, so you're going to have to be careful that you don't burn stuff down. You can pause this and read this disclaimer now if you need to. So this DIY is to convert the existing fuel strip on a 2007 R1200RT to a float using the FC2 kit supplied by Bert Prohm at his website, proebeemer.nl. At that site you can see that he supplies a few different kits. The one I'm using is the Float Control 2. At this website he's got manuals for this particular conversion. They're kind of skimpy, which is part of the reason I'm putting this DIY together. He's in the Netherlands. There's a 6-hour time difference with where I'm at. There's some communication issues because he's in the Netherlands. He was good at replying to my emails, but he didn't always give me the details that I needed. At this particular time that I was doing this conversion in late 2020, early 2021, there wasn't much online references about this conversion. I did find a few YouTube videos where it was used on a GSA, but nothing on an RT. Those are here. So there's the link for part 1. And the link for part 2. If you have a GSA, you might find these helpful. While I was doing this project, I had to develop my own YouTube video to show him some issues I was having, and this can give you a bit of an idea of the work that's going to be involved if you want to check it out. There's the link for it. Also, when I was working on this, I had a post going where I was asking some questions at the MOA forum. And there's the link for it. And thanks to everyone that helped me there. Once I got this done, we closed this thread, and there's a discussion thread at the MOA forum. And this is the link for it. Alright, so basically, here's the outline of everything that we're going to cover in this DIY. We'll start with a little background about fuel strip woes. We'll talk about some calibration methods that you can consider. It's important to note for this kit to work, you have to have a good, proper calibration of a good fuel strip. I'll give you an idea of the tools, the parts needed, and their costs, and then we'll just step through all these steps. Basically, we're going to remove all the plastics we need to get to the fuel pump and remove the fuel strip, do a calibration on the fuel strip, take the float that's in this kit and attach it to the fuel pump, do some tests on the float to make sure it's working. You do have to install a longer vent tube inside the fuel pump because the OEM vent tube interferes with the float. You have to install a relay and a fuse, and then the FC2 controller itself, which is some electronic work you're going to have to do. I'm going to cover this right here, upgrading the quick disconnects on the fuel pump from plastic, which I suggest you do if you still have the plastic ones. And then we're going to put it all back together. You may have to do some tweaking, which you can do on the FC2 because there's a potentiometer inside. And that's about it. So let's get started. On the fuel strip woes background section, I pretty much cover the fuel strip woes. If you're here, you should be familiar with them. I'm not going to read all of this. You can pause now and read it if you want to. I will go ahead and click on all these links because these are some great threads that I came across, and I want to provide you the opportunity to go to these links. It all started with this fuel strip poll on the MOA website. And there's the link for it. There you can find out how to do a NHTSA report, which I suggest you do. If enough of us did it, we could potentially force a recall, but that's never happened yet. One of the most informative posts I found is here. And within that post, I found how a fuel strip works. Down around reply 48. how a calibration works. Around 124. How to test them on the bench. Around 127. The zap method that can fix a bad fuel strip but doesn't always last a long time. That was around post 253. Unfortunately, these images are no longer there, but it's a good outline of what you do. A fix to give your fuel gauge a constant full reading, if you're interested in doing that. It's not too difficult. Involves getting some resistors. That's around 240. A look at what the inside of a fuel strip looks like. That's around 547. Like I said, the zap post lost all of its really good pictures, but you can search YouTube for zap fuel strip and you'll come up with a couple pretty good videos that show you how to do it. Basically, you're using a charcoal lighter, modifying it, and zapping the fuel strip to repair it. I was also led to this thread, which shows a good finished product for the resistor fix. Not there yet. At this link in this YouTube video, you can see this fix being used. Where he actually clears his code while he's doing his conversion. There's been some reports that this doesn't work for everybody. I don't know why. I've tested it. It worked fine for me. I went to NTE Parts Direct and ordered these resistors and wired them up, and I'll show you what it looks like later. This is another good thread, covers a lot of the same material, but in different detail. So you might want to check this out if you're interested. Basically, when I was doing all this research, there were a couple of options, it seemed like, for a float conversion for an RT. And one of them was this company. And then, of course, proebeemer. And I decided to go that route. I also stumbled across this thread, which detailed some fixes for the K series and the GS series, but this particular fix didn't seem to work for the RT because there's a different wiring harness in the RT. But if you've got a K series or GS, you might want to check out this thread. The kit that you get for the RT from proebeemer includes this, what I call the FC2, which is the float control. This box has an LED in it, a potentiometer, and embedded, it's got chips to have the embedded software in it, which basically takes the float measurements and converts them to fuel strip measurements that the ZFE is looking for so that you can get a good fuel gauge reading. This is the float itself, which you attach to the fuel pump inside the tank. It hooks up to where the fuel strip used to hook up. So as I mentioned, you have to have a good calibration. If you've got fuel strip codes because of a bad fuel strip, they're going to have to be cleared out before his kit works. The only way to clear them out is to do a good calibration. You can pause now and you can see what your options are. What I'm going to cover here is doing them with a GS 911 and a good known fuel strip. It is possible to build an adapter to allow you to attach a good fuel strip to the ZFE without pulling the fuel pump. I worked on this for a while and it was successful, but it's not really the preferred method. Preferred method is to hook your good fuel strip up to the bottom of the fuel pump after the fuel pump is removed from the tank. Basically, this is what it ends up looking like if you build this adapter. You attach the fuel strip. You see that the fuel pump is still in the tank here, so it's just a workaround. Here's a list of the parts that I needed. I'm not going to go to all these links. You can basically go to these websites, punch in these part numbers, and find this information yourself. Here's the costs. This is not a cheap fix. Here's some bits and pieces that I needed along the way. And here's a list of all the tools that I used. Some of them might be optional in your specific situation. The costs that I give you were mid-2020 for my RT. I rounded them to the nearest dollar, and if you needed to pay shipping, I included those charges. Alright, let's get on to the work. You're going to have to drain the fuel tank. I rode till mine was almost empty before I started. You should take a picture of your fuel gauge before you get started so you know what the level was, what the miles remaining were, and what your odometer was. You're going to need to remove the seat. Basically, you just unlock the rear with your key by the license plate. If you've got heating, you need to disconnect your heating and just flip up the seats to do that, and then get them out of the way. Next, you'll take off the tank rail where your tank bag latches. It's pretty easy. 4 T25 screws, both of them the same length. Then remove the left-hand trim panel. You got a screw up by the dash there. You got one by the accessory port there, and you got two up front. Then they tell you to disconnect your powerlet plug. That's pretty hard for me to do because the plug sits back behind another panel that's attached here, and the lock is on the other side. It's hard to get to. I find it's just easier to take this other panel off, and so I include that. There's 4 T25s. Basically, to get the left-hand trim panel off, my tech had forgot to put one of the screws back in on my bike. And so the additional panel I take off is this panel here, off of the left-hand trim panel. It's held on by these 5 screws. 2 of these screws are longer. It goes here, 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 and down here. And I just take that off because it's easier than messing with the powerlet plug. I wanted to look and see if I could turn the powerlet plug around where the lock would be on the right side, and you can do that. Here's where I kind of left myself notes about where the long ones go in that picture above. So here you can see that the powerlet plug, there's a lock ring. You can loosen this lock ring, you can turn it around where the plug faces the right way, but when you do that, then the cap for the plug flips down instead of up, and I was worried that there might be some water intrusion, so I decided not to do that. Here you can see my beat up plug. Once I got it out, it gets beat up because it's so hard to stinking unlock. Next, we remove the left fuel tank cover. So it's got some screws down here that are longer than the rest. Then it's got screws along here and here and here and up front. It's got a plastic catch here that's showing you that detail right there. You just twist it and take it out. Here's what the screws look like. Those are the 2 longer ones I showed you. Everything's still T25s. Next, we remove the fuel tank cap. It's just 6 screws all the same. Put a rag in there to keep any trash from getting in until you get this all cleaned up real well. Then we remove the center fuel tank cover. Taking out these screws. It points to a few other screws, but they were already out. You got to carefully remove these posts from underneath the openings in the parts that it matches up with, so be careful with that. Here's the screws that come out. And then clean everything pretty good on the tank. And the next step is lift the filler neck and the gasket up and unhook the fuel strip. So your fuel strip's in the fuel tank. It attaches here. You're going to bend these prongs up and then unattach it from the filler neck. Now, as I said, there's a vent tube in the tank we have to replace. That's this tubing right here. It's attached to the filler neck. It goes in the tank. And then it comes through to the fuel pump, and it's attached underneath the fuel pump here. And there's a tube that goes through the fuel pump cap. And then it passes through the cap, and you have another tube that's attached here on top of the fuel pump. And this tube goes down and goes underneath the fuel tank along the frame. And then it turns and goes down by the kickstand and just hangs open to the atmosphere here. And the purpose of this tube is to vent pressure inside the tank and any overflow gas. And so it's important to note that the OEM tube is this short one here. It's only about 2 feet. We end up buying a meter from Max BMW and using almost all of it inside the tank to route it a different way so that it doesn't interfere with the float when you put the float on. It's also important to note that this tubing, don't be tempted to go to the auto parts and buy a 3/16 fuel line, because it's not rated to be immersed in fuel long term. And this tubing is inside your tank. It's immersed in fuel all the time. If you have any leaks, any clamp problems, if it deteriorates because it's the wrong kind of tube and it leaks, you can potentially empty out your gas tank on the floor because of the way this tube vents through the fuel pump. So all of your gas could come through this and end up on the floor of the garage, which we don't want to happen. In order to take the tubing off of the filler tube, it's got crimped on clamps, and I replaced these with some screw-on clamps later on so that you don't have to have the special tool to crimp the clamps on. If you've already got that tool, that's fine. If you use Oetiker clamps instead, that's fine. But to get the crimp-on clamps off, you just insert a small screwdriver in them, pry them open, then put a medium screwdriver in and keep prying them open until you can get them off. Then take an awl and force it into the hose and move it all the way around the hose barbs to break it free, and then you can pull it off. These are the clamps I bought to replace them. Fairly cheap, except you had to pay for shipping. Made them a little more expensive. Once I got the filler neck off itself, I found that the passage that the tube attaches to had some rust inside it, some dirt. I had to clear that with a stiff wire. This is the replacement meter of tubing I got from Max BMW. Here's the part numbers that I outlined previously. Like I said, don't be tempted to go to the auto parts store to get that tubing. Also, on Max BMW's parts fish, they made a claim that if you wanted to replace the OEM clamps with screw-on clamps, here's what you needed. Well, I bought them and they were the wrong size. So don't be tempted to do that either. Don't get these clamps. Those clamps are that stinking big. Obviously too big to clamp down. I did send them an email and I documented that that part number was wrong. Here's the part number for the meter of hose you're going to get. Here's the part number for the OEM clamps if you want to get them. Do not get these. Now it's time to disconnect everything from the fuel pump. You've got a couple of quick disconnects here and here. You basically push in on these disconnects and hold them open while you pull this tube out or pull this tube up. This is the overflow vent tube I talked about. It's not clamped on, you just pull it off the post. Here's your two electronic connections, your harnesses. This one goes to the ZFE, this one goes to the fuel strip inside the tank. This is what mine looked at before I started. You can see I still have the plastic quick disconnects, which I replace later. Here's your first disconnect. You push in on this and hold it while you pop this out. If you don't do that and you just try to pull these out, you're going to destroy the O-rings. So you don't want to do that. You can see here we've got the same crimp-on clamps too that are going to get replaced later when I replace these with screw-on clamps. Here's the second one disconnected. You can see that this didn't actually pop back out into place because of all the dirt and everything that had to be cleaned up. Here's the two connections unplugged, and I took this photo. They're not swappable. One's only a 3-pin, one's a 4-pin, but you can see here that these pins are recessed, and that'll be important later on. We'll talk about that. To actually get the fuel pump out now, we have to take this lock ring and unscrew it. They have a special tool for that. You can do it with a hammer and a screwdriver, but later on when you install this you need to torque it down, and you can't do that with a hammer and a screwdriver. So I bought the special tool. Wasn't cheap. It basically sits on top of this lock ring and it grabs 3 of these, whatever you call them, that are sticking up, and allows you to unscrew this lock ring. Here's the tool. They call it a pin wrench. Odd name. I also got a new fuel pump gasket. If yours is in good shape and it isn't too old, you can reuse it. I didn't know how old mine was, so I went ahead and changed it. There's what the special tool looks like when you put it on. It needs a 1/2-inch breaker bar or socket and a 1/2-inch torque wrench later on. And there's what it looks like after you remove it. Note that the fuel pump flange itself, and all of this is plastic, has a tab to orient it correctly within this white ring. When you go to install this all back, you want that tab oriented right here. You want to make sure that this white ring did not move at all because of these tabs, and I didn't have that problem. When you go to pull, you still have this hose attached, and you can use that to pull on carefully. Underneath here, there's a flange that you can also grab with some pliers if you want to. I wouldn't grab anything else out here. This is your fuel pump controller. So they tell you, you know, don't get up underneath this rim with a screwdriver and try to pry. You'll break it. Don't pull too hard. Slightly pull. And that's what I can tell you is the key. Just grab that hose, rock back and forth, and put a little pressure on, and be patient, and pretty soon you're going to break the seal on the gasket and it's going to pop up. Once it pops up, you can pull the fuel pump out a little bit. It still has the vent tube attached to it. Here you can see the gasket still installed and how it fits in that white ring properly. Here's the lock for the fuel strip connection, which is here. All these locks are just a small screwdriver, prime and pull. Just be careful that you don't break them. So after you get the pump out, you got to do a good calibration if yours was bad. If your calibration wasn't bad, if you had a good fuel strip, you don't have to worry about this, but it's important to note, once you disconnect everything and you're working on the electronics for your kit, don't ever turn your ignition back on until your kit is completely assembled. I made a mistake. I knew this, but I did this project over 6 months and I just basically, you know, got frazzled one day and wasn't thinking. And I wanted to test the operation of the relay that I installed, and sure enough, I turned the ignition on, and as soon as I did, I had my duh moment. And I knew, well, now I'm going to have to calibrate. So don't make that mistake. This is a picture of the resistor fix that you can do to clear the code and not have to calibrate. I did build this and I did confirm that it gives you a full gauge reading all the time. I did not confirm that it clears the code. So I can't speak to that. Some people say it does and some say it doesn't. But this is what mine look like. I actually used one of the adapters from the harness I built to bypass the fuel pump. And so mine looks a little different than what you see in the posts I provided earlier, but it's the same basic set of resistors. Now, I did have a problem when I built mine. On the posts that give you the resistors and show you how to wire them together, they speak of pins 1 through 4 on your fuel pump. And my adapter was labeled pins 1 to 4 as well, and I just assumed that this adapter would hook up pins 1 to 1, 2 to 2, 3 to 3, 4 to 4, and that's not the case. And I didn't realize that till I got done. But this is opposite. So it goes pins 1 to 4 and 4 to 1. Well, I soldered everything together like this and tried it, and it didn't work. And then I figured out what had happened, and I had to reverse them. And this is the proper way. You can tell here that 2 resistors are going to white, and here 2 resistors are going to blue. So I had to reverse them basically. After that, it worked fine. The preferred method to calibrate if you don't have a good fuel strip, is to get a good fuel strip. You can buy one. They're expensive at the dealer. They're a couple $100 at max. They do have them on eBay, but you know, that can be risky. You could borrow one if it's the same model from a friend. I was fortunate. I still had a good fuel strip. You use a GS911, a Wi-Fi in my case, hooks up to the diagnostic port, which is under your seat by your battery. Here's the battery. Here's the diagnostic port. When you do this calibration, using the GS911, you want a battery charger hooked up because you don't want your voltage to drop during the calibration. And basically, once you get your GS911 hooked up and your charger hooked up and your fuel strip hooked up underneath your fuel pump, then you just fire up your software, do an auto scan, clear all the codes that the auto scan detects, and then run the calibration. And you can find all that information on the hex code website, the maker of the GS911. There's your display for the calibration in progress, for the calibration completed. And then you just unhook everything. And from this point on, like I said, don't turn your ignition back on. Another mistake I made caused me to damage the float that I got from proebeemer. And that was, I attached the float to the fuel pump before I disconnected the vent tube from the fuel pump. I originally wanted to make sure that the 2-foot vent tube would not work because his directions weren't real specific. It said it may interfere. And so I had gone ahead and I'd hooked the float up to the fuel pump, and I was going to do some testing. And sure enough, the tube did get in the way, and so then I had to unhook the tube from the fuel pump. And in doing so, I put a little pressure on the float somewhere and basically caused this hairline crack in the scale. And that completely disables the operation. The fuel pump reads resistance along this scale, and that broke the resistance. So if you have the same problem, I'm going to show you that you can get a float on eBay and you can replace this base. It's important to note how these wires hook up to this scale. It's possible when you go to put these back to do so incorrectly and then not get good resistance readings, so make note of that. I was able to track down another float because on my float I saw those part numbers, and I was able to buy this float. It's got a different arm, a different float, but it's got the same base. Here's the link for that float on eBay. Paid 20 bucks for it and only used the base. The most important thing about this is that base has to have the same resistance readings of his kit. And that float did. It's like from 60 to 300 ohms, something like that. Once you get that kit, you have to carefully disconnect the arm, these wires. You do that with an awl in both cases. And then you have to put your original wires back in that have the plug on it and your original arm back in. It's not too difficult, you just need to be careful. You also have to drill the mounting holes in this new base, and you do so just by transferring them to the new one. Here's your instructions on how to drill them out, so make note of that. Now you can take the fuel strip out of the tank because it's disconnected on both ends. This is your old fuel strip. And I didn't note, I think, that when you do the calibration, the fuel strip has to be out of the tank and dry. The good fuel strip. So anyway, here you have where the fuel strip is supposed to lock inside the tank. Some techs don't put this in place correctly, which leads to some of the failures in the fuel strip, but you just basically pull it out. And it's easier to get out of the fuel pump hole because it's larger than the filler neck hole. This is the plug on the float, and the developer makes note in his manual that you should check this gap here. Sometimes he tries to make this modification for you, but he says sometimes he forgets, and sure enough, in my case, he forgot. Here you can see this has not been modified, and it's too narrow to fit on the mating part underneath the fuel pump. And you have to take a utility knife and basically whittle it away. It needs to be about 5/16 long. You also want to be careful with this seal when you're attaching this to your fuel pump. It is possible to pinch it, which I did. And I had to find a replacement, and I found this connector through DigiKey, which is also where I bought the other connectors and the pins I needed. And I cannibalized the seal off of this connector. I also noted on my float that I had this void in the insulation. There was no damage to the wiring, but I asked about this. He said you didn't need to worry about it, and it didn't seem to affect the float at all. So now we're going to actually install the float on the fuel pump. And you can see here what side of the fuel pump it attaches to. It attaches to this flat. You want your holes to go through this flat. You have to be careful that you're not too close to either side or they won't go through. You also have to attach it at the right area, and his instructions said make sure when the float's in the full down stop that it's right above this filter. So that's what you're looking at here. You also have these connectors to the float. You have to be careful that they don't get pinched on your actual tubing, your fuel line. And I just used a clamp to hold it in place while I was working on it. And then I marked the holes on the fuel pump and then took the float off and did the drilling. Here's your instructions on how to do this, and you'll see in my final location I was a little higher than the previous picture. I pretty much got it as high as I could without putting a lot of stress on this connection. Once you get it attached, you want to test the travel of the float, and I found that I had a couple of problems. The arm hit the tubing, and so I had to make some adjustments here by carefully, and I mean carefully because I didn't want to break this scale again, hold this arm and bend this out a little bit to clear it, and then bend this back in a little bit so it's still in the same orientation in the tank. I also found that it scraped on the second screw, which is now underneath the float arm holder. And so I removed that screw and ground the head down just a little bit, not a whole lot, so that it passed over it. And sorry for the blurry photo, but this screw was ground just a little bit to do that. Now we want to bench test the float inside, well, outside the tank, so that you know what resistance you're reading, so that you can confirm that your float isn't binding in the tank later on. To bench test the float, you've got to take resistance readings. Well, excuse me, to bench test it, you don't have to, and it's easy to get to the float because you're basically just going to put your multimeter leads. I put them in here actually. You can hold them here. I put them inside here. And then you're going to move the float, or you can hold them out here. But you're going to move the float and make note of the resistance readings. Once your fuel pump is installed, you're going to have to do the same thing here. And like I told you before, these pins are recessed and hard to get to. So for a few dollars, I found a connector at Napa, and I modified it to be able to go down in this and make it easier to do the resistance readings once the fuel pump's installed. And this is a 2-pin connector I found. Had to do some grinding to it along here. And I didn't keep this part number, unfortunately, but that's what it looks like. And then this just goes in the middle of that connector for pins 2 and 3. And it looks like this later on. And it's real convenient then to hook your leads to these wires instead of trying to get down into that recessed area. You may have, some clamps for your multimeter leads, and you can get down in there and you don't have to worry about this. But basically, we're going to right now take measurements while this is on the bench of your float in full travel, all the way up, which is what you see here, all the way down and in the middle, so you know what your good resistance readings should be. We're also going to test this once we put the fuel pump in by attaching a string to the float and putting that string through the vent tube in the fuel pump. Since the vent tube isn't connected right now, you can do that. This photo shows it connected because I was at a different stage when I took this photo. But here's what it looks like when your vent tube's not connected, your string's coming through, and you can do your testing and you can do your resistance readings and make sure they conform. If you happen to have your vent tube already connected, you can run it through the opening as long as you don't crimp it. Don't crimp it between your fuel pump and the white ring. You would do that without the gasket on. So I made an actual video inside the fuel pump as I was doing my test, and it's here, and you can watch it, and you can see the float travel all the way up and down. With the OEM fuel vent tube in place, it runs across here and attaches to that vent, and that's why it has to be replaced. I think previously I showed you My readings on the bench were 60 ohms at fuel top stop, full fuel level, 130 ohms in the middle, 285 ohms at the bottom stop. Once I got it inside the tank and put my adapter on and did this test, I had 60 ohms, which showed me that I was going all the way to the top stop like on the bench, but I only had 215 ohms. And that's because inside the tank, it doesn't drop all the way down. It hits the side of the tank. And I tried to do some finagling and some adjusting on the float, but I could never get it completely clear. And I lived with this, and it didn't seem to be a problem. So now we're going to put the longer vent tube in the tank, now that we've confirmed that our float's working like it should. This is basically just a diagram to give you an idea. The old vent tube just ran along like this to connect, and it interfered with the float. Your longer vent tube is just going to come straight down the fuel pump to the bottom of the tank, then run over to the back of the tank, and then run up to the filler neck. Before you do this, make note here, you want to make sure you get your gaskets in place on your filler neck and on your fuel pump before you attach the clamps, or you'll cause yourself a problem. When I was routing the tube, I noticed this rubber bit in the bottom of my tank. Tried to figure out what it was, and come to find out it goes in the filler neck, and it's what the gas pump goes into in the filler neck to prevent backsplash. Apparently my previous owner had been rough on it. It had split and it had been pushed through into the tank. This part does not show on the parts fiche. Couldn't find anything about it with those numbers, and determined, since I hadn't missed it before and couldn't find a quick replacement, that it wasn't important. Here's the longer vent tube attached now with the gasket in place. You can see that the clamps I bought fit a lot better than the ones that Max suggested I use. Here it is attached to the fuel pump. Here I show you how I routed it down the fuel pump in between this area here to help hold it in place, and I put a zip tie on to hold it so that it doesn't wander once you put the fuel pump down in the tank. Here's the fuel pump gasket in place around the white ring. You've got an upper rim here, and then you've got a rim underneath the white ring and a wall here. And all this has to be in place before you install the fuel pump. You're also going to lubricate this inner wall so the fuel pump will slip in. I used Vaseline. But now you can put your fuel pump and your float back in the tank after attaching your vent tube, and check your resistance readings again to make sure your vent tube is not interfering. And the way you can do this now, I just set the fuel pump on top of the gasket. I did not push it down and seat it at this point. And if you do that, your resistance readings will be off just a little bit, but you'll still be able to tell that they're okay. And I added 1 gallon of gas, made a resistance reading, added another, made a resistance reading, added another, made a resistance reading, so I could tell that the float was moving like it should. And the reason I didn't seat this yet was I was going to attempt to test this the actual operation of this kit before I buttoned up the fuel pump, and you can do that. It's okay to do that if you want to. Now it's time to do the electronics. Basically, there was a lot of discussion on whether you needed a relay, and it was decided that you do. I don't know for sure. I'm not an electrician, but I decided to use a relay. And I decided to use, for the trigger of the relay, the power line from the diagnostic port, because I already had a tap off of it for some rear LEDs that I did. And that was all discussed on this thread. When I added my Skeen LEDs, basically the blue-green wire off the diagnostic port I had tapped into already, and it was easy for me to tap off of that. Again, I want to reiterate, do not turn your ignition on now that you have everything disconnected, or you're going to have to calibrate again. Here's the relay I ended up buying from Max. You can see here that the terminals are numbered 1, 2, 3, 5. There's also a schematic right here which shows 1 and 2 as your trigger, 3 and 5 as your relay. Here's my drawing of how I put this together. Basically, off the battery, I'm running straight to the relay on terminal 5. I do put an inline fuse here for protection. I have my tap coming off the diagnostic going to terminal 2 on the relay. Terminal 1 is just ground for the trigger wire. And then number 3 is the actual power lead to the FC2 up by the fuel pump. And these two wires, there'll be a ground wire also going with it, will be routed along the frame under the tank like the vent tube. And this is what the relay schematic looked like, which just shows that the trigger is 1 and 2. When the trigger's energized, the open relay closes and current goes from 5 to 3. This is a photo of how I assembled all this. In my scenario, I've got a power commander that sits on these two supports by the battery. And I found that the relay right here fit between those supports nicely, and I just Velcroed them to my power commander. So after figuring out I was going to put the relay there, I ran hot wire with an inline fuse around to 5. This is my wire from the diagnostic port going up to my LEDs, and I just tapped off of it. I'm a fan of posi lock and posi taps, and I use those for electrical connections. I also run my wire inside plastic tubing. But this comes around to 2, the trigger. I've got a ground, which comes around to 1 for the trigger, and then we have 3 running off and down the frame along with the ground off the battery going to the FC2 by the fuel pump. And there's my inline fuse. I had this plug-in fuse available from a posi lock assortment I had bought previously. I did have to source a few 1 amp fuses on Amazon, plug-in fuses that look like that. And with my power commander in place, my fuse is tucked up underneath there. You can't see it. So This is what we look like at the fuel pump side. Now this picture is everything reassembled and we're not there yet, but I'll just point out everything to you. Power from relay terminal 3 in the ground comes out here from under the tank, and it energizes the embedded software in the FC2. This is what used to be hooked up to the ZFE to get fuel strip readings, and now you're actually hooked up directly to the FC2. This is the same original OEM harness to the fuel pump that is hooked up to the ZFE, no changes there. This is now what is relaying the converted float readings. This embedded software takes the float readings, converts them to what the fuel strip readings would have looked like, and now feeds it back to the ZFE. So this used to plug in directly here to the fuel strip. It now plugs into the FC2. And 6 is the powerlet accessory port that goes in the left trim panel. It's now time to install the fuel pump. And basically, it's okay now to, once you've got all your electrical connections made and everything hooked up to the fuel pump, you don't have to put the fuel pump in the tank. You can actually test your float now, test your FC2, make sure it all works. I suggest you have 3 gallons of gas in the tank at least before you do this, because actually more, 4 gallons probably, because if your FC2 calibration isn't correct, you may test it and find out that you get nothing on the gauge, which happened to me, and you might say, oh man, what happened? And then end up doing a lot of work like I did trying to figure out what happened. And actually, all that happened was the calibration of the FC2 was way off, and I had to have more than a half a tank of gas before it registered. I detail all that here, and so read it and decide what you want to do. When it's time to put this all back together, they want you to put a little paste. Like I said, they talk about tire fitting paste. I used Vaseline around the inner surface of this gasket all the way around. Then you put the fuel pump down in and you realign the tab I told you about before with the white ring. And then basically, carefully, as I detail here, just kind of rock this down until it goes into place. If you push too hard, you're going to force this gasket into the tank and have to start over. You just got to go slow. Then you need to put your ring back on, and you need to torque it down. There's your torque value, 35 nanometers. Okay, now you can put the center fuel tank cover back on. There's your photos. You can pause if you need to. I'm going to go through these kind of quick. Put your fuel tank cap back on. They do have a torque value for that. I suggest that if you have the plastic OEM fittings, you buy the Beamer Boneyard kit, and at this point you go ahead and replace them. After your fuel pump is locked in place, you can work on this. These are what the cheap plastic fittings that should have never been engineered. These end up breaking, leaking, and they're going to cause you a problem eventually. You know, for 80 bucks you can get this kit. These are manufactured by the same company that manufactures the plastic ones, so they fit perfect. They'll last forever. You get replaceable clamps. You're going to take this thread sealant and you're going to put it around these threads. You're going to let this sit for at least an hour. Then you're going to thread this into the fuel pump. You're going to make sure that you hand tighten it, and then another half a turn with your wrench, 19mm wrench I believe. Don't go any tighter than that or you're going to crack your fuel pump and be sorry. Put a little oil on these O-rings. Put a little oil on the hose barbs before you attach the hoses to make them easy to slip on. You get a couple of spare O-rings. And if you did all that, now go ahead and put everything back in place. And you're ready to roll. You can put your seats on now. And you can ride and you can test. And I want to caution, when you go to attach the FC2, situate it along the fuel pump, don't put it on top of your lines here because you don't have enough room. You may think you do. You may put this on and go ahead and be able to attach it. If you've got plastic quick disconnects and you do that, there'll be just enough pressure here that you're going to cause a leak in this quick disconnect down here, I guarantee it. Can you get by with it with the metal ones? I don't know, but I'm going to tell you, don't even try. Put the FC2 over here next to the quick disconnects so that it is here. And what I did was I put a piece of Velcro right on this ring, right in the middle here, and underneath the FC2. And then I also took this twist tie and put it through a couple of these underneath here to hold it all in place. Worked well. So now you can ride, you can check for any leaks, you can watch your miles remaining computation change. I pointed out previously, I don't think I talked about it here, but I pointed out that that computation only changes after your rear wheel is turning. So while you can turn on the ignition and get the fuel gauge to show, that computation doesn't change unless you, and you can do this with the bike on the center stand. You can put it in second gear and let your rear wheel turn carefully, obviously, and get the computation to change, or you can ride now and you can watch it. But basically now, before you finish up, everything's buttoned up. You can ride. You can get your give the FC2 time to stabilize, get your fuel gauge to stabilize, check for any leaks, see where you're at this point. Then you can put the left fuel tank cover back on. Then you can put the left-hand trim panel back on. However, if you're not completely satisfied with your fuel gauge level and you want to try to tweak the FC2 to get it more accurate, leave this panel off. Don't put it on. We can put this on at the very end. Of course, you will have to reconnect this panel as well here if you took it off like I did. Put your tank rail back on. And then we're basically at the tweaking point. If your fuel gauge looks good, you're happy with it, you've already put your left trim panel back on, you're done. If you're not, and you would like to get the fuel gauge a little more accurate, you can tweak it. There's a potentiometer in it. Basically, you have these 4 small Phillips screws. You take them out carefully pry apart the base and the top cover. The only thing that's really going to give you any resistance there is the silicone that was applied to your wires. And once you break that seal, the top cover comes off fine. When you go to put that cover back on, you got to make sure that these are all orientated correctly and that your cover goes back down in the seal. I did not bother scraping the silicone off. Replacing the silicone, I was happy with it. Just don't pinch your wires. Here's your potentiometer. There's the screw for it, small jeweler's flathead. Here's the LED. I previously explained how this thing cycles on and off every 30 or 40 seconds. It takes its readings and it updates the fuel gauge, and then it cycles off 30 or 40 seconds and then repeats. So the developer told me clockwise causes the fuel gauge to go up, counterclockwise causes it to go down. I had the exact opposite experience, and I can't explain it, and neither can he, but I suggest you just test yours carefully. He does say don't make any large changes all at one time. He says it could confuse the software, so I would make no more than one full turn at a time and allow everything to sync and then repeat if necessary. You can ride with this open as long as it's not raining and you're not riding through wet roads, obviously. But I would ride, I would adjust, I would ride, I would adjust. I also wanted to know what my resistance reading should be now for every gallon of gas in my tank. And I tested that. I actually siphoned out all the gas from my tank and then I added 1 gallon at a time. You could go in reverse. You could fill up your tank and then you could siphon out 1 gallon at a time, but I wanted these resistance readings just to know what was happening. And I showed you that previously my empty was 215 and my full was 60, and you can see here that between 5, 6, and 7 we're not getting anything. So the gauge is topping out after 5 gallons of gas. I learned that this isn't a big problem and that the fuel gauge was still working pretty good. Now, as I said, originally I had to fill up my tank basically before my gauge showed me anything, and then it only showed me a half a tank. And so I did have to do a lot of tweaking here to finally get a fuel gauge that read full when it should, and that gave me a warning at 1 gallon left in the tank as it should. But it is possible, and I'm still at the point of doing a little fine tuning. I want to point out that at one place when I was tweaking, I could actually have a full gauge and then while I was at a standstill get the low fuel warning, flashing warning on the fuel gauge, which made no sense, but it's like you're out of the full range, and I had to come back down a little bit to make that disappear. It would disappear when I was riding. If I was at highway speeds, it would show full like it should, and then if I stopped, it would flash out, and then if I started, it would show full like it should. But once I tweaked it just a little more, I got that to go away. So basically, I got a full pretty much gauge. I had ridden a little bit here. My full reads about 300 remaining, and I was happy with this in the end. It was a lot of work. I made a lot of mistakes. I learned a lot, and hopefully from this I can keep you from making some of the same mistakes and make your job a little bit easier. So I've got this thread open like I showed you before for discussion, but you have to be a member of BMW MOA in order to post questions there. You can put comments on this YouTube if you want. I will monitor it a little bit, maybe try to answer your questions there if needed, but I can't guarantee it. I hope you found this helpful. And I will stop here back on these steps and leave it for now. If you decide to take this on, good luck, and hopefully you'll have an easier project than I did because of this. Take care.